Hello again. This section we will go through the microbit code for Intel OpenBot Lite. This is the code in full. It looks complicated, but with the previous expansion board and microbit test code's explanations would have put you in a very good position to understand this code. Let us start with the onStart. There are two portions you may not be familiar. Let me start with the bottom portion. These are the global variables that will be used throughout the program, and they are given startup values here. Let us review the hardware block diagram of OpenBot Lite before we move on to the next section of OnStart. The mobile uses USB to serial communication to communicate to microbit, and microbit P15 is used to receive serial communication from the mobile, while P16 transmits serial data to the mobile. Together with the expansion board, microbit is able to control the left and right sets of motors and the LED indicators. Serial redirect block is to set up P15 to receive data from the mobile and P16 to transmit data to the mobile. This serial communication baud rate is set at 115200. The highlighted portion on the block diagram shows the serial communication section. On the physical hardware, it is the mobile, USB OTG cable, USB to serial converter module, and its wires connected to the expansion board. Let us look at what happens when the mobile app transmits data to microbit. There are two types of data. First is the motor command. This is an example. The lowercase c indicates this is a motor command. The first number is the left motor direction and speed. After a comma, this number is the right motor direction and speed. If the number is positive, the motor should rotate forward. If it is negative, it should rotate in reverse direction. 255 represents full speed, while 0 is stop. The last character is the symbol for new line. Next command is for indicator LEDs. This is represented by a lowercase I. The next number states the LED's states. -1 means blink right LED. 0 means off all LED. And 1 means blink left indicator LED. The last character is a symbol for new line. Let us see how serial on data receive new line decodes and use this serial data. For example, microbit receive these motor commands. Temp2 will store this string without the new line symbol at the end. Next, the first character on temp2 is extracted and stored in command variable. The command is compared to see whether it is a motor command. In this case, it is. Hence, this section highlighted will run. Let us have a closer look. Remember temp2 contains this string. Temp2 string is split at command character and it is stored in data array. The first member of data array is empty as there are no string before C. Second member of the data contains the string values of the motors. The second data member is split at comma and stored in data2 array. The first member of data2 is the left motor numeric string, and the second member of data2 is the right motor numeric string. Next, we will convert data2 members from string to integer and store them respectively to control left and control right variables. This will be used in update left motors and update right motors functions. These two if statements are to check and prevent from processing erroneous motors values that was caused by communication noise or error. If the motor values lesser than -255 or greater than 255 are very likely to be such errors. We will see at later section how these two functions, update left motors and update right motors functions, use control left and control write variables. The bottom portion of serial on data received new line handles the indicator command. Here is a recap on what is an indicator command. I indicates that this is a command for LED indicators. The next number indicates the state of the indicator. -1 means blink right indicator, 0 means off, and 1 means blink left indicator. And the last symbol is a symbol for new line. For example, microbit received this indicator command. Temp2 will store this string without the new line symbol at the end. Next, the first character on temp2 is extracted and stored in command variable. As it is not a motor command, it will not do the first if section, but the second. Temp2 string is split at command character and it is stored in data array. The first member of data array is empty as there are no string before I. The second member of data array contains the string of the values of the indicator. Next, we convert data to second member from string to integer and store in indicator value variable. This will be used in update indicator function. Now let us look at update left motors and update right motors functions. First highlighted box handles reverse command as control left and control right are negative in order to enter this if section. The temp variable stores the positive form of the control values. Next section handles forward command as control left and control right are positive in order to enter this if section. The last section handles stop command as control left and control right are 0. This section stops the corresponding motors. Note these two highlighted portions. Temp2 contains a positive value of the corresponding motor speed. As the mobile app gives the motor speed in the range of 0 to 255, we need to map to 0 to 100 in order to fit PCA 9685 duty cycle. This highlighted block does that. Last but not least, update indicator function and the forever loop. Update indicator function is called every 0.5 seconds as indicator interval is 500, which represents 500 milliseconds. The first section of update indicator function handles the blinking of right indicator LED. The second section to switch off all indicators LEDs, and the last section handles the blinking of the left indicator LED.